Okay, welcome back everyone. In this video, I'm actually going to prove the law of conservation of energy. And we're going to do this by starting with what it means conceptually for energy to be conserved. If any physics quantity is conserved, that means that it doesn't change from one time to the next or from one situation to another. So when we say that energy is conserved, what we're really saying is that the total change in energy, or rather the change of total energy, is zero. And we're kind of showing a simplified version of this, but this tells us that our final energy will be equal to our initial, but it's also a change in energy total, which is made up of potential energy and kinetic energy. And those have various types, so if you want to get into the different details, you can talk about the different types of potential and kinetic energies, but we're not going to go there right now. We're just going to say, well, I have to apply this change to each of the terms. So change in potential energy plus change in kinetic energy. And by the way, this has to be equal to zero, and this leads us to kind of a neat side thing, which tells us that the change in potential energy of an object is always equal to the negative of the work done. And if you have already seen a video on the work energy theorem, you'll recognize that this is because if we bring kinetic energy change to the other side, the change in kinetic energy is simply the total amount of work done. So that's sort of an aside, but that's not really our main focus. Our main focus here is to say that a change in anything, okay, so delta whatever, is equal to final minus initial, right? So what we have here is potential energy final minus potential energy initial plus change in kinetic energy is kinetic energy final minus kinetic energy initial, and we just said a moment ago that those two changes must be equal to zero. So where do I go with this? Well, I can collect terms and I can say potential energy final plus kinetic energy final is equal to potential energy initial plus kinetic energy initial. And another way of saying this is that potential and kinetic energy final is the energy final of the system, and potential and kinetic is the energy initial of the system. And we're just talking about mechanical energy. We're not talking about any situations where there's energy lost to heat or friction, because then our starting premise, namely that the change in energy is equal to zero, that wouldn't be true if we had only if there's no friction or energy lost to heat. If that's not the case, then our starting point is not valid. Okay, so anyways, this gives us conservation of energy, okay, that final energy is equal to initial, and that's pretty much it.